section with unit circle stuff. So if you have your unit circle around somewhere, it would be a good idea to get it out. All right, so where we're headed is this. The sine of x function, y equals the sine of x. If you look on your unit circle, okay, what is the sine of 0 degrees? 0. The sine of 0 is 0. Okay. What is the sine of, and then we're going to use radians for this, not degrees. What is the sine of pi over 6 radians? Come on. 1/2. Thank you. What is the sine of pi over 4 radians? Square root of 2 over 2. What is the sine of pi over 3 radians? What is the sine of pi over 2 radians? 1. And then we'll do a couple more. But then I'll take you through the full thing a little later today. Let's do 2 pi over 3. That would also be, and 3 pi over 4. And let's go to 5 pi over 6. 1/2. And at pi, we're at 0. So, if you look at a graph of this, the x-axis, if I say, well, since pi over 6 is divisible by 6, and pi over 4 is not divisible by 6, but they're both divisible by 12, if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces if I'm at pi, pi over 6 would be 2 spaces over. 2/12 is 1/6. Pi over 4 is the same as 3/12, so that would be there. Pi over 3 would be the same as 4/12, so that would be there. Pi over 2 would be 6/12, 8/12, 9/12, 10/12 to get to those. Okay? And let's put 1 right here, 2 right here. So your sine of x function starts at 0, 0. At pi over 6, we're at 1/2. At pi over 4, we're at square root of 2 over 2. And you go, well, what is that? Well, if you take the square root of 2 on your calculator and divide it by 2, it's like 0.7071, isn't it? Which is about right there. Square root of 3 over 2 is even a little larger than that. What is square root of 3 over 2? 0.866. So it's about right there. And then once we get to pi over 2, we're at 1. And then here we're at 0.866, 0.7071, 1/2, 0. It makes a nice smooth curve like that. Now, if we would keep going, it would make a nice smooth curve under here and go back like this. This is called a sinusoidal curve. It's like a heart rhythm monitor, which goes up and down and up and down and up. It just goes up and down and up and down forever. Okay? We've had coterminal angles, and you just keep going coterminal angles forever all the way around, and it'll go up and down forever. Okay? That's where we're getting to. Now, in this first section, we're not going that far. The first section, we'll have a few problems where it'll simply ask you, what's pi over 6? Well, sine of pi over 6. Well, that's 1/2. What's the cosine of pi over 2? Well, that's 0, and so on. So you'll have to answer some questions like that. You already know how to look on your unit circle to find those. Then, what we're going to do this chapter is we're going to take this sine of x curve, and maybe we're going to add 1 to it. Well, when you had your function y equals x squared in algebra 2, and you added 1 to it, what happened to the graph? Everything went up by 1. What if something happened inside the parentheses when it was x squared or x minus 1 quantity squared? What happened to the graph? Everything moved? Actually, right 1. Because if it's inside the parentheses, it moves the opposite way of what you think. Okay? So we're going to be doing that in here because we're going to do y equals a sine of b times x minus c plus d. D for Mr. Bierschbach's not being able to write right. He gets a D. Okay. A sine of b times x minus c plus d, where a will be the amplitude, b deals with the period of the function, c is a phase shift, right or left, and d is a shift, is a vertical shift, which means up or down. So we'll be doing this for sine curves, and we'll be doing this for cosine curves. We'll be doing this for tangent curves, cotangent curves, secant curves, and cosecant curves. We're going to graph all 6 of them. And by the end of the chapter, if you work hard, and if you're careful about learning how to graph these, you'll all get 100% on your test. But not everybody works as hard as other people in here. And not everybody gets 100. Should you all get 100 on this one? Yes. Okay? Because I give you half the answers on the review test. You have half the test already done for you when you do the practice test. Because the first 6 problems on the practice test are the same as the first 6 problems on the test. They're just in a different order. There should be no way anybody misses the first 6 questions. Do I every year have people miss something on the first 6 questions? Yes. It shouldn't happen, but yes. And then the last 6 questions are very similar to the practice test. So if you work in this chapter, you should get 100% on this test. Generally, I get about 75% of the class gets 100 on this test. Okay? So if you want to get a good grade, this chapter is a one to really bounce your grade up. Okay? And keep, because you can very easily get 100 on this test. Okay. Now, what we're going to work on in this first little mini section is this. Okay? If I'm at a point 3, 2, and I have a phase shift right by, I should say not 3, 2, pi 2, sorry, by pi over 2. Okay, where am I going to be at? If I'm at pi 2 and I have a phase shift right by pi over 2, where's my new point going to be? Well, if it's right or left, it affects the x variable, right? Okay. A phase shift to the right by x makes it 3 pi over 2, 2. Because we just add pi over 2 to the pi. Well, 1 pi over 2 plus 2 pi over 2 is 3 pi over 2. Okay. Okay. What if we're at negative pi over 4, 0, and we have a phase shift right by pi over 2? Where's my new point going to be? Well, the y value is still going to be 0, but what's the x value going to be? Well, we're at negative pi over 4, which is negative 1/4, right? What's negative 1/4 plus 1/2? Positive 1/4. So we're going to add pi over 4, 0. Okay? All right. Now, let's do phase shift left by pi over 3 and down 1. We're going to do phase shift left pi over 3 and down 1. Right now, let's say we're at pi 3. If you do a phase shift left by pi over 3 and you go down by 1, where are we going to be at? Well, if we go to the left, we need to do what with the x value? Add or subtract? Subtract by pi over 3. Well, pi is 3 pi over 3. Pi over 3 is 1 pi over 3. 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. If we go down by 1, 3 minus 1 is 2. Okay? Let's do that again for a different one. Let's say we're at pi over 6, negative 2. Now where am I going to be at if I phase shift left by pi over 3 and I go down by 1? Where is my new point going to be? Pi over 6 minus pi over 3 is 1/6 minus 1/3. 1/6 minus 2/6. Negative 1/6, so negative pi over 6. Negative 2 minus 1. Negative 3. Okay? So you'll have some problems like that. Then I'll want to know the point halfway between pi over 4 and 3 pi over 2. Oh, pi over 4 is 0, and 3 pi over 2 is 0. What's point halfway in between? How do you find halfway of something? Well, you can find the average of it. How do we find the average of two numbers? Add them together and divide by 2. Okay? So pi over 4 plus, what's 3 pi over 2 in terms of 4? Well, it's 6 pi over 4 and divided by 2. Well, 1 pi over 4 plus 6 pi over 4 is 7 pi over 4 divided by 2. Well, if you divide by 2, that's the same as multiplying by 1/2. So 7 pi over 4 times 1/2 is 7 pi over 8. So halfway in between those 2 points is 7 pi over 8, 0. Add them up and divide by 2. Let's do that one more time and I'll let you get started. Halfway between negative pi over 3, 3 and pi over 6, 3. What's halfway in between those two? Well, you take negative pi over 3 plus pi over 6 divided by 2, which is negative 2 pi over 6 plus a 1 pi over 6 divided by 2. What's negative 2 pi over 6 plus 1 pi over 6? Negative pi over 6 divided by 2, which is the same as multiplying by 1/2. So it would be negative pi over 12, 3 would be the point halfway in between. Page 116. We're going to do 11 through 49 every, it might be 47. I think it's 47. 11 through 47 every other odd. What in the heck does that mean if Mr. Bierschbach says do 11 through 47 every other odd? The first question you do is 11. The second question you do is 15. And then you do 19. And then you do 23, and so on. Okay, so do these in your notebook. Okay, don't rip out the paper. I'll come around and I will look at your notebooks when we're done with a section. So we'll have maybe 3 or 4 assignments out of section 2-1. Okay, and then I'll look at your notebook. Then we'll have a couple assignments out of section 2-2, and then I'll look at your notebook and so on. So I'll grade your assignments once we're done, but we're going to do this today out of this section, and we're going to do it Wednesday out of this section. Okay? So get to work on this, and then I'll come back and we'll start talking a little more about graphing after a bit.